So what have we seen with these last two examples? We first saw a example where the domain was all real, but then it got complicated. We took the square root of something. Now, when we take the square root of something, that something cannot be negative because then it would result in an imaginary number, and we're not dealing with imaginaries. We're talking about real numbers. So when you're trying to find the domain and it's the square root of something, that something better be non-negative. So we need to think about what x values will make this greater than or equal to 0. Also, we had a fraction. A fraction has a numerator and a denominator, but when you're dividing by something, that something cannot be 0 because we just simply cannot divide by 0. It is undefined. Look at these four functions. They all have the same domain. This is a line. This is a parabola. This is what is this? This is a line with a slope of 3 and a funky y-intercept of 2 radical 13. And what is this? This is a parabola with an a value of 1/3, a b value of 2/3, and a y-intercept of -7/3. So I got 2 parabolas and 2 lines. Very simply, the domain for all of them is all real numbers. Quadratics go left and right forever, and so do lines. So do linear functions. Linear functions go on left and right forever. Here is our last example. And it looks intimidating, but we got it. And this is a combo. God knows what this function looks like. I have no idea, but it's broken up into 2 parts, it looks like. I've got a 1 divided by x, and then I'm subtracting the square root of something. Now, with practice, you're going to be sensitive to this. You're finding the domain. 1 divided by x, you really need to be thinking, I know I can't divide by 0. So this thing can't be 0. And it happens to just be simply x. X cannot be 0. So you kind of jot that down. But you got another part of the function, the square root of 2x plus 9. Now, you can't take the square root of a negative number. So 2x plus 9 can't be negative. It must be positive or 0. This should say positive or 0. And this is how you write that mathematically. 2x plus 9 is greater than or equal to 0. So these 2 things, guys, explain your domain sufficiently. This sufficiently describes your domain, but we need you to be good at interval notation. So we need to somehow express the same idea using an interval. Again, imagine the whole number line. And first of all, x cannot be 0. So there's a hole at x equals 0. So that divides our solutions on a big interval on the left and a big interval on the right. What about this? 2x plus 9 is greater than or equal to 0. Well, you want to find out what the domain is. Domain is x. So let's just solve for x. You would subtract 9 and divide by 2, getting -9/2. X has to be greater than or equal to -9/2. And -9/2 is about 4.5. So here it is. You've got what intervals are involved here? Numbers have to be greater than or equal to -9/2, but they must also be, but 0 is also forbidden. X cannot be 0. Even though 0 is greater than -9/2, 0 is completely out of the question because when x equals 0, you actually divide by 0. So here is our solution. We just need to convert this to interval form. And we have 2 intervals. We've got an interval from -9/2 to 0, and then everything past 0. So there it is. Including -9/2 for the bracket, excluding 0, so parentheses, and then adding on to that the second interval, everything past 0 and on into infinity. Now the graphs are, we love the graphs. They should be our best friend because the graphs, they make almost everything easier. And this problem would be a piece of cake if we had the graph. Here is the graph. And as you can see, it doesn't even exist to the left of negative 4.5. That's because any number that's less than negative 4.5 would have you taking the square root of a negative. And also notice this asymptote. This is what it looks like graphically when you try to divide by 0. It is discontinuous. There's a break right here because we cannot divide by 0. So this portion of the graph is accounted for by this section, 1 divided by x. So the domain is everything from negative 4.5 to 0, all these x values, and then also all the x values past 0.